everyone, I am Anita Tekellapati, a graduate student in computer engineering. Now, I came up with a topic called silicon photonics, which is the bridging the gap between electronics and the photonics. In this topic, I want to give you a brief on what is silicon photonics, why we are using it, what are the components that are included in this, what are its advantages, applications, and its future scope. Coming to the photonics is the science of light generation, detection, manipulation through emission, transmission, modulation and signal processing, etc. The highlight role of photonics in modern technology is very wide and its applications are so far like from communication to healthcare. It is having wide range of applications. The silicon photonics is an innovative and rapidly evolving trending technology that merges with photonic systems along with the silicon microelectronics. Silicon photonics is indeed a fascinating field that leverages both electronic and optical properties of silicon, which is why we are calling it as bridging the gap between photonics and electronics. By utilizing the silicon as an optical medium, this technology integrates photonic circuits with silicon-based electronic circuits, which leads like providing us the high-speed data transmission, communication. It also helps in high bandwidth and also provides us high energy efficient data communication systems. It is traditionally celebrated for its semiconductor properties, which is making it as the backbone of modern electronics. Why we are using silicon photonics? The silicon photonics is compatible with all the technologies, especially with the CMOS technology, which is the standard for manufacturing electronic chips. This compatibility allows for the integration of electronic and optical functions on a single chip. It also helps in high-speed data communication, where the transmission and communication is done very quickly. It also provides us high energy efficiency, low power consumption, reduced size, also scalability and future proofing. The scalability and future proofing is the most important one, where the scalability impacts a lot in the silicon photonics due to its compatibility with existing fabrication technologies, means that it can meet the needs of various applications ranging from simple devices to complex integrated circuits. It also provides broad application spectrum and it overcomes the limitations of electronics. So it is having many advantages and many operations to be performed. That is why we are gonna use silicon photonics in most of the technologies. Coming to the components of silicon photonics, it is having like waveguides, modulators, photodetectors, lasers, resonators, multiplexers, demultiplexers, etc. The silicon photonics is a technology that utilizes silicon as a medium to build optical components. Here are the key components of silicon photonics. The waveguides. These are the fundamental building blocks of silicon photonics, which are used to guide light signals with minimum loss. The modulators. These components are used to modulate light with data by changing the intensity phase, or also called the polarization of light. Electro-optic modulators in silicon photonics often utilize the plasma dispersion effect. And coming to the lasers. Lasers in silicon does not naturally emit light due to its indirect band gap property. So lasers in silicon photonic systems are often made from materials like indium phosphide or gallium arsenide that are bonded to silicon chip. The resonators, they are like typically used for filtering specific wavelengths or enhancing the interaction between the light and the modulating signal in the modulators. Micro-ring resonators and photonic crystal cavities are examples of resonators that are used in the silicon photonics. The multiplexers and the demultiplexers are the devices which are used to combine or split different wavelengths of light respectively, which enables dense wavelength division multiplexing to increase the bandwidth over fiber optic cables. So these are the components that we're going to use in the silicon photonics, which is like each one is having its own importance and significance in the silicon photonics. Coming to the applications, as we already discussed, the silicon photonics is having wide range of applications, starting with the communication and ending to the healthcare. It has applications like telecommunications, data centers, sensing and imaging, LiDAR systems, consumer electronics, high performance computing, etc. The integration of these components into a single silicon-based platform allows for the creation of compact, high-performance optical systems that are crucial for a variety of applications, from high-speed data communication to quantum computing. It is having wide range of applications in automotive to medical applications. Along with the applications, we do have some advantages. The integration of all these components into a single silicon-based platform allows us for the creation of compact, high-performance optical systems that are crucial for a variety of applications, from high-speed data communication to blossoming and quantum computing. The first one is like high bandwidth and data transfer speeds, where it has high speed of data communication and data transmission. Even after having the high speed data transmission, it is only consuming low power. As the power is very low, the heat operation is also reduced. The reduced size in photonic circuits can be made compact because of the high refractive index contrast in silicon-based materials, which allows light to be confined in very small waveguides. The low power consumption is also very important, especially at high data transfer speeds. They are also making sure by reducing the size and weight, also the cost efficiency is also maintained. It provides good cost efficiency along with the enhanced security and also the high performance. The silicon photonics is already having wider range of applications with wider advantages, but in order to the future scope, they are expected to make some more significant contributions, and they are the integration with next generation computing technologies, the advanced telecommunications infrastructure, photonic integrated circuits which are called PICs. They're gonna expand the photonic integrated circuits. The consumer electronics is also a key area where they are expected to make the significant contributions. To conclude about the silicon photonics, it is a transformative technology that bridges the gap between electronics and photonics, offering significant advancements in how data is processed and communicated. The main impact on the industries is like it is providing faster and more efficient and sustainable technological solutions with high performance and low cost. The ability of silicon photonics to miniaturize and reduce the cost of optical components also expands its potential applications from ultra-fast internet infrastructures to advanced sensor systems in automotive and medical technologies.